Hello, it's me, Oscar from Marijuana Garden.
Alright, picture this. One of the greatest showdowns in science. Einstein versus Bohr. For over 100 years, these two giants argued about the very heart of reality, all centered on one mind-bending experiment, the double-slit. Now, MIT physicists have just pulled off the cleanest, most precise version of this legendary experiment ever. And believe me, the quantum world has never looked so sharp. Let me break down what they did, and why it matters. The classic double-slit test asks, is light a wave or a particle? When you shine light through two slits, you get a striped pattern on a screen, proof of wave behavior. But if you try to watch which slit the light actually passes through, the pattern vanishes. Suddenly, light acts like a particle. For decades, Einstein argued you could, in principle, measure both, wave and particle, at the same time. Bohr said nope, the universe won't let you. But here's where MIT's new experiment flips the script. Instead of using physical slits, they used single atoms as their slits. Super cool, right? They fired an ultra-weak laser so faint that each atom could scatter at most a single photon. This was quantum minimalism, stripped down, avoiding any mechanical interference. And the results? Any attempt to measure the path of the photon, even at the tiniest scale, made the wave pattern disappear. The more precisely they tried to observe which way the photon went, the less visible the interference pattern became. You could dial up the atom's fuzziness and make light act more like a wave, or sharpen it and see more particle-like behavior, but never both at once. So, what does this prove? Einstein's idea that you could somehow outsmart the universe and catch both natures at the same time just doesn't hold up. Bohr's vision, that wave and particle are mutually exclusive realities depending on how you look, has won, once and for all. What's wild is, by removing even the physical hardware, the MIT team showed it's the quantum relationship between photons and atoms that sets the rules, not the stuff we build in the lab. This isn't just a technical win, it's a philosophical one. It means our universe really does draw a line in the quantum sand. You can look at the wave or the particle, but never both together. Imagine telling Einstein and Bohr a century ago that it would finally come down to single atoms, single photons, and pure quantum magic. Science fiction made real. Thanks for joining me on this quantum journey. If you want to dive deeper, check out the full study and physical review letters. And keep your mind open, because in quantum physics, reality is always stranger than you think.